Hello, everybody. It's Mrs. Pound, and we are studying waves in chapter 6.1. And today we're going to talk about different parts of the wave from section 612. So, our objective today is just to describe the parts of a wave. So, let's start with the top part, the crest. This is the highest point of a transverse wave, and we call it a crest just like we would call the top of a hill the crest of a hill. And the lowest point of a transverse wave is the trough. And think of it as a feeding trough that an animal eats out of, or a trough, a watering trough that they drink out of. It makes a depression to hold their food or their water. The wave height is the distance between a trough and a crest. So this whole distance here is the wave height. There's also the amplitude. This is the maximum distance a wave vibrates from its rest point. So this is the rest point here, this line, and this is the amplitude. So you can see that the amplitude is equal to half of the wave height. Now, amplitude and energy are directly proportional. What this means is that if one goes up, the other goes up. So if amplitude goes up, the amount of energy in the wave goes up. And an example of this is with sound waves. If I get louder, the amplitude has gone up, even though that's a longitudinal wave, but it is a good example. Now, what I want you to do is, if you're listening, write tsunami next to this bullet point, because a tsunami wave is very tall, it has a very high amplitude, and obviously has a lot of destructive energy. Now, if a wave's energy increases, the amplitude of the wave increases, as we can see with a tsunami wave. And if a wave's energy decreases, the amplitude of the wave decreases. Now, another thing we look at on waves is the wavelength. This is the distance between corresponding points on a wave. So, say between two crests or between two troughs. So, it's one complete wave, one up and one down. Okay. Now, wavelength and energy are inversely proportional. What that means is if one of the quantities gets bigger, the other is smaller. So the shorter the wavelength, the greater the energy, and the longer the wavelength, the lower the energy. Do you see how they are opposites? So inverse, think opposites. And then there's also a quantity, and this is not a part of the wave, but this is a measurement about waves that we make, is the frequency. This is the number of complete waves that pass a particular point in a unit of time. So let's say that this wave travels this far in 1 second. So one wavelength in 1 second, it has a frequency of 1, okay? Um, if it traveled this far in 1 second, it would have a frequency of 2 because 2 wavelengths have passed that point, okay? So wavelength and frequency are inversely proportional again. That means if one goes up, the other goes down. So if frequency decreases, wavelength increases. Just like, and I have a radio in the background because radio goes by frequency. What you're tuning into are different frequencies when you're tuning your radio. And so the higher the frequency, actually, the smaller the wavelength. So the higher frequencies, the higher you go, the smaller the wavelength is. And if the frequency increases, the wavelength decreases. And then the last quantity is period, the time it takes two successive wave crests or troughs to pass a given point. So for this, for example, if this was 1 second, um, it would take, so one complete wave, 1 second, okay? Now, if there are More waves that pass that point, it would be a shorter period of time. The period would be shorter. And when we think of the word period, think of periodicals as well. These are things that happen over and over again. Periodicals are reading material like magazines or newspapers that come out at certain times. And so that's where they get that name period from, is the fact that it has to do with time. Now, if it took that wave 2 seconds to pass that point, it would be, uh, the period would be 2 seconds. Okay? So our objectives were to describe the parts of a wave, and we just talked about a number of parts of waves, and you're going to have to be able to label a wave on your test. So you have to know these parts and what they are. So don't forget your 5 questions, and there's one more section in this chapter.